Welcome to the third day of the Virtual Precision Agricultural Conference and Ag Technology Showcase. Today, I am pleased to introduce Zach Harmer. He is the North American Sales and Global Support Manager at SoilOptix, and he will be discussing how to make soil mapping technology a tool in the Precision Ag Toolbox. So without any further ado, take it away, Zach.
Alrighty, Ainsley, thank you so much. And it's a pleasure to be speaking to everyone online here today. Exactly what Ainsley just mentioned, just basically just trying to walk through of how we can make soil mapping technology really that tool in a precision ag toolbox and being able to adopt that. And one of the key things kind of as part of that title is sort of precision ag. And of course, everyone that's here at the conference is well aware sort of precision ag. We're sort of all invested in some capacity, but I kind of wanted to just take a couple seconds here to sort of go back to the basics of ultimately what precision agriculture is, right? And the definition from the International Association for Precision Ag defines it as essentially precision agriculture is the management strategy that gathers, processes, analyzes temporal, spatial, and individual data and combines it with other information to support management decisions according to estimated variability for improved resource efficiency, productivity, quality, profitability, and of course, sustainability of agricultural production. Now, that's a mouthful. There's no doubt about it. But if we really look at it more concisely, again, coming from the ISPA here, that precision agriculture is a management strategy that takes account of temporal and spatial variability to improve sustainability of agricultural production. That's looking at inputs, right? Fertilizer, amendments, seed, water. How can we grow a more productive crop with, let's be honest, more stresses on that production, right? Climate, if it's more rain, less rain, more heat, less heat. We're losing obviously a little bit of land to urban development, of course. So how do we become more productive while looking at that spatial and of course temporal variability? Now, precision ag tech is huge, right? And I always look for this graphic to sort of be released every year and identifying what are those farm tech companies out there, right? And this is 2020. It's extensive, right? It's massive. And I don't even know if this touches even all of them, right? So how do we begin to really bring all of this together a little bit more? And I'm going to be focusing obviously a lot of my conversation here today around, let's say, the soil sensing and analysis component, right? But when I sort of preparing for this presentation, I was identifying, when I look at a graphic of precision ag, what does it involve, right? And this sums it up really, really well. We've got application data from, let's say, sprayers or spreaders. We've got application data from planters. We've, of course, got application data maybe from irrigation pivots, right? And of course, we have information regarding tiling, scouting, grain coming in and out of the elevators. And then naturally, of course, one of the, I would say the baseline for precision ag, which of course is, let's say, yield data coming from the combine. But I noticed two things are sort of missing in this graphic. One is satellite imagery, right? Which I know a lot of us have heard much about satellite or drone imagery as a means for creating management zones and management decisions in precision ag. But another key piece that's also missing is soil, right? And that's kind of interesting to me to really see that sort of missing. So, I'm kind of looking at it as, where does soil really fit into this system? Right? I think we can all agree, and we all know obviously sort of what the role of soil information really is in general for basically production of crops, right? It's using it as a determination of current soil parameter levels. If that's nutrients, pH, texture, and of course now more than ever, we're seeing sort of this carbon component being brought in, right? And it's also a baseline data input for management plans. Right? Is that the management plans for inputs, again, fertilizer, seed, water. But it's also used for that identification, let's say, of coming back to the law of the minimum, right? What is that limiting factor that's potentially reducing yield? As we know, as you reduce or don't have, let's say, that balance in that soil across, let's say, all of those properties, that's where we can begin to lose some of that potential. And one of the things that also is part of this is, of course, is the temporal and spatial data set that you can provide or get provided through, let's say, the soil information. So what are some of those methods of collection ultimately? right? Well, one of the things that we sort of look at here, certainly at SoilOptix, is, what is that traditional practice of field soil measurement, right? I think we can all agree, and I'm sure some of us who have even seen some of these graphics before, but when we look at sort of the spatial component, right, what is that variability across the field and how can we achieve that? So we have standard sample pulling, such as 5 acre, let's say traditional, and probably the most standard is 2.5 acre grid sampling. And then you can get down into your 1s and then half acres as well. But one of the key things as part of all this too is as that grid size decreases, our price tag goes up, right? And how do we mitigate some of that? How do we still achieve, let's say, the accuracy, the variability, and the information that we can gain from maybe a half acre grid and even more, but at the same either price, around the same price, cheaper, or maybe just slightly more than maybe 2.5 acre grid, right? Now, one of those pieces that have tried to answer that question, of course, is maybe through zone sampling, right? And some of that basics really relies on maybe guys creating zones through yield data, satellite imagery, drone imagery, maybe even some of the soil mapping technologies on the marketplace now, right? Where it's trying to collaborate or try to build sort of general zones in the field based on maybe productivity, right? But one of the things that I like to sort of think about and ponder in all of that sort of system as well is, should all your nutrients be classified under one common management zone? Should your phosphorus and your K and your pH potentially follow the exact same boundaries, right? It's a question I always like to ponder, and something that I think we can sort of, that's where grid sort of comes in, as being that, again, it diversifies some of that boundary, but again, can come at a cost if we're really not achieving some of that half acre resolution, if you will. Now, one of my most favorite graphics, and this is from Devron Veritas, and I do have the privilege to be able to use this one as well a little bit more, but it's understanding, how do we get to that actual detail, right? How do we go from maybe that traditional bulk to grid? And as we move through sort of these various sampling methods to zone, and then of course the soil sensing equipment, we're getting closer and closer to that actual detail. And I think this is where we really want to sit ourselves, right? In between that soil sensing equipment and the actual what's going on out there. Now, one of the things I always like to mention too is, for our stewardship, right? This is going to be huge coming down the pipeline, and we're starting to see it already from pressures maybe outside of agriculture. So how do we as an industry continue to also bring in some of this information into the Precision Ag Toolbox to achieve, let's say, these 4 R's, right? Right source, right rate, right time, and right place. And I think this is where soil mapping technologies really start to answer that question, right? Soil mapping technologies such as, of course, SoilOptix, Veris, EM machines, either sleds like these that are pulled on the ground, or other technologies that, of course, that are on the market that are maybe raised above the ground. When you look at sort of these various technologies, they all have their pros and cons. There's no doubt about it, right? EMEC carts are active tools. They provide, let's say, subsurface information, not only, of course, on top of, let's say, that topsoil, right? Creating zones for the purpose of maybe going out and pulling those soil samples, right? On the SoilOptix side, of course, where I'm from here, speaking to you today, is a passive sensor that essentially is looking at what the soil is telling us. It acts as a sponge, right? And when we combine that sort of with soil samples as well, but in a little bit more strategic sense in the field, we can then dilute or dissect essentially that data into providing individual soil property layers. So in all of this, what we're trying to do is really just discover these pockets of opportunity, right? That's what we like to think about it here. And it's utilizing, let's say, topsoil predictive modeling in the sense that what SoilOptix really does. Okay. And when I say pockets of opportunity, you're probably like, well, what does that really mean? Right? Well, it's identifying these, right? The smallest of pockets, the smallest of acres in the field that really may not have been picked up by even some of the soil samples themselves. This is the strength that you can start to find with respect to, let's say, soil sensing equipment, right? Bringing something across the field that's actually reading what is going on in the field at some of the highest resolution available. All right, so this is a picture, let's say, of typically what a survey would be shown as inside the field with a SoilOptix machine. And of course, we're combining that still with physical soil samples that are pulled, right? But one of the key things is, what does this technology, really any technology with respect to soil mapping, let's say, really represent? Well, it's representing essentially that variability of the field with respect to the soil itself, right? And if I just take a quick second to sort of hone in maybe on these 4 samples that are circled here on the screen, we can see that as we go from maybe yellow to light blue to red to dark blue, we can see that change in soil, even in some of the smallest fields or even some of the biggest fields, right? So point 1 being sort of yellow, it's sort of that mid-grade. Getting to the light blues, that's where your aggregates start to decrease. We're getting into more sandier soils, less organic matter. The reds in that map from a radiation standpoint are going to be a lot higher, right? So we're getting into more clays, more organic matter material. And of course, on the opposite side of that spectrum on 0.5, let's say, we're getting into these dark blues, right? So that's low radiation, so that's lighter soil, more coarser soil, less organic matter, okay? So ultimately, where's the value in all this though, right? So what, right? And that's the big thing that I always get the question of is, okay, that's all nice, but what does this really mean to the management that I'm doing in my field? Well, one of the key pieces I like to also mention is the repeatability of this data captured over time. Again, that temporal piece coming into play here, right? When we look at sort of data collected maybe September 26th of 2018, and when you pull a sensor across that field, you want to have the confidence that it is repeatable time after time, right? So we look here about 6 months apart, over winter as well. We've got a fertilizer application in between these two. And from a SoilOptix perspective, we have 2 different sensors that actually came across. So we can have the confidence that when we go in 2018 or even the fall of 2021, we can be confident we can utilize that sensor data time and time again, right? Again, bringing value to the grower, right? For that investment in that first year, let's say, that we can continue to add value time after time, crop after crop, sampling season after sampling season, right? So what are some of those utilization opportunities though? Well, I think that low-hanging fruit really is variability application. This is, again, bringing now full circle into what is precision ag, right? We have the application equipment out there. We saw from Colin's presentation yesterday with the clean seed technology of the precision that we can really get with seeding technology. And I can only imagine that that's going to become even more prevalent within, let's say, maybe fertilizer amendment application too. So again, we could do variable rate fertilization, potash, MAP or DAP, right? Amendments, maybe it's liming, right? And various types of lime, of course, trying to achieve what is needed in that soil. Another piece that we could start to see, and we do see certainly here in Ontario, is some variable rate seeding, maybe based off of texture. And I'll kind of get into that shortly. And maybe there's even irrigation. Now, I know that irrigation, of course, here in Ontario, outside of maybe some permanent crops or even vegetable crops, is fairly limited, certainly in the broadacre side. But again, if we look to Western Canada or other parts of North America as well, there's opportunities with utilizing some of this information to really drive irrigation and water management decisions. So I want to take this time to kind of go through, some various examples of how we can really bring in soil mapping technology as compared to maybe traditional, more generalized approaches into this toolbox so that we can really try and optimize those inputs as we go into the fields. And I would say one of our most used examples, if you will, if you've seen some of these presentations, but it continues to sort of hammer home the point, is when we look at, let's say, one of the first fields that we ever ran with SoilOptix here in Ontario, and looking at a 1 acre grid versus SoilOptix. And you can see a 1 acre grid, as we sort of talked about, does provide a very good detail when it comes to grid sampling, right? It's laborious and does cost a little bit, obviously, but it does give you that good sense of where that variability exists. And we can see that, right? But when you bring in, let's say, some sort of technology that introduces the ability to map with a sensor, combine it with soil samples, we can even fine tune even some of the smallest zones on a 1 acre even further, right? Getting more granular on our data. We can see that here on, let's say, again, more red area, let's say in the southern part of this field, in the center part, and of course into the north, right? And we're really sort of focusing on, of course, the lower pHs in this field, right? Fairly similar ranges, let's say around 5, low 5s up into essentially the mid to high 7s, right? But how do we then translate this into an actual field application, right? The so what? So when we look at sort of that 1 acre grid, and we applied this application management decision or prescription here, we could see that we're about 104 tons of lime total, ranging anywhere between, let's say, about 0 pounds to the acre, roughly up to about 8,000 pounds, Okay. One of the key things that I like to say about this field here is that, of course, we have 63 acres at 0 pounds to the acre. And keep that number in mind as we sort of look at the optics side. So we're calling for about 140 tons more, or 140 tons total lime. So roughly about 38 more tons. But again, 63 acres at 0 pounds to the acre, right? So the same sort of area that doesn't need any sort of amendment. But what we're doing is we're honing in on those areas that have maybe been a little bit overgeneralized, even on 1 acre grid, right? And being able to apply this at a very high resolution, right? And basing it off of high resolution data, trying to bring more data points into that prescription grid as much as possible. Now, as I mentioned, of course, that sort of talks about the spatial component, right? We see where that changes across the field. But one of the things that we can also start to look at is the effectiveness of temporal information, understanding where that change happens, when it happens, and influence, of course, management decisions that we've made previously and how we can see that in fields today. So when I come back to that field was done in 2013. It's about 8 years ago now. And when we look at it back in 2018, again, this is pH. We're seeing a nice balanced soil now, right? And I'm sure that if we went back in 2021, we would either see similar, maybe a slight reduction. It's probably that lime has likely been used up now at this point. But at this point, now we can just do touch-ups, right? We've gone to the areas of the problem. Now we would just need to do some touch-ups, right? And that's sort of the strength is when you take this through multi-year studies, this is where we can start to really see the improvement of soils just based off of high-res data, right? Trying to hone in on those areas that really need it. In this instance, this is one of our more research fields, if you will, in Western Canada, in Alberta specifically. Again, we have a 5 acre grid that was done in 2011, and this grower went and applied gypsum on this field to combat essentially some of their sodium problems. But what that had done actually, ultimately, is reduce the pH, reduce the calcium, and reduce the magnesium, and bringing that field collectively into a state of flux where it's not entirely balanced, and we don't have the most fertilizer efficient soils out there, let's say. So in that first year, we were roughly about 5-6 total, or on average, across that field. And in 19, after we applied a CKD lime rec onto this entire field, in 19, we saw about a 5.9. 2020, it was about a 6.1. And in 2021, that field was just sampled only a couple of weeks ago. So while we wait those results, we'll be able to see sort of if that CKD lime has actually fully released, and if we just need to do some touch-ups at this point now. Similarly to calcium percentage, right? We saw that reduction after 2011, and then now we're seeing that improvement into 19, and then into 20, it was about 50%. And again, similarly in magnesium percentage, right? Had dropped down after that gypsum, and now we're just trying to really bring that back up. So again, that's sort of looking at maybe amendments, right? A little bit of nutrient in there too. But one of the things that I think has always been overlooked when it comes to soil, certainly in precision ag or just in general, is sort of texture, right? Where does the texture come in? And when we look at sort of these soil mapping technologies, this is really the backbone of a lot of these. And we can now start to understand more fine-tunedly what's going on with respect to textures inside these fields. Of course, we have historical data, right? We have the Canadian Soil Survey. Maybe there's county soil surveys as well. These are publicly accessible, but they're very, very general and don't really hit the smallest of points maybe in that field that could be explaining easily maybe some crop responses. Obviously, the influence of fertility availability, right? A pH, as I like to say, a pH of 6 in a sand is much different than a pH of 6 in a clay, right? So how do we begin to sort of bring texture in to answer some of these questions? So of course, texture, water moves, right? But does it move to a sand or a clay, right? How is it being related, of course, to topography, as we know too? VR seeding, can we begin to introduce texture information into maybe some of this variable rate seeding application or site-specific irrigation potentially? And as we start to see other technologies with respect to soil, can we begin to look at soil moisture probe locations, be more fine-tuned on where we actually put those? And this is a great example here. The smallest of little areas in this field, roughly about 100 feet wide. It was about 67% sand. And you can see that bean crop, not too bad, right? Middle of the summer here. And we can see as we go just about 150 feet to the east, a little bit higher sand, about 75%, and we can see the response of that crop. Now I know you can't manage texture, you can't change the texture of your field, right? But are there other instances that you can put in place, other management decisions that you can put in place to really bring this crop back to at least being somewhat productive? Right? Is a reduction in seeding rate? Is it a increase in maybe water? Is it a difference in fertility management, right? And although with the SoilOptix technology, we can dissect it down into clay, sand, silt properties independently, but can we bring this back to just what we know as the soil triangle, certainly here in Canada, right? And develop just maybe a single layer that responds to just texture, right? And here is a great example of where a 3-zone management decision could be made based just off of texture. A sandy loam versus a medium loam, and then a few spots in that field that are clay loam. Right? These are the opportunities that we can now start to really bring, let's say, mapping technologies into this precision ag toolbox. One of the last examples I kind of wanted to talk about today, because I've sort of talked about obviously fertilizer application, I've talked a little bit about amendment application, but one of the things when I sort of sit back and I'm speaking to folks sort of all around North America is, when we're driving in the fields, we're collecting that information in the field, specifically from a combine, right? And it's kind of answering that why question, right? Why am I seeing what I'm seeing when I'm in there? So if we look at this yield data from wheat, let's say in 2018, obviously we have we have some very nice spots of wheat yield, and then we have some more, let's say, reduced spots, right? And why? Why am I seeing what I'm seeing there? So when you look at maybe the site-specific grid, you can get some correlation there, right? If we're looking at just K-Meg ratio, let's say. Right, we can see in that southwest corner of the field, it's obviously a higher K-Meg. We're seeing a response from a reduction in yield in that area. We're getting into maybe some 0.2s, 0.3s, let's say on the east side, and we're seeing a bit more response, let's say, positively to the yield. But when you bring in a mapping technology on top of that, that's where you really start to tell the story. Right? We can now start to really fine tune of why am I seeing what I am seeing. Right? We're seeing that response. We're seeing a direct correlation right here with yield and now K-Meg. So now this grower can go back out and apply management decisions at a very fine-tuned scale to really address the problems that are possibly in this field. And if we want to dive into even some other layers as part of that, if we look at just magnesium percentage, right, we can see again that relationship. But one thing again, as I've mentioned previously on a couple slides ago, is texture, right? Clay available water. It's a SoilOptix specific layer where we're looking at essentially clay, silt, and organic matter. And here we can see quite a decent relationship with yield. So can we utilize that information as well as other fertility properties to drive management decisions here to really bring a more, let's say, balanced soil across that field so that we can get a more uniform crop, right? And just one last piece. Again, of course, when I sit here, that's all fine and dandy until you put dollars and cents to it. Right? How do we really make this pay for itself? And of course, we've all seen it. Obviously an increase in input costs are going to be coming here in 2022. There is no doubt about that, right? So utilizing technologies like SoilOptix, like other soil mapping technologies will only help obviously improve the inputs that we're putting into those fields and optimizing those dollars and cents ultimately of what's going on. So when we look at maybe just a simple grid, a very large grid, about 5 acres roughly on this field. And when we look at maybe the grid pH on average, about a 5.4. So the lime rate roughly is about 2,400 pounds. On average, it costs about $128 an acre, right? But on the optics side, we can see that we actually found some pockets that are a little bit higher, right, than what the grid was showing, right? So on average, we were about a 5.9, which reduced that lime rate, which in the end actually saved grower some money on this one, right? Is this going to happen all the time? I can't say that for sure. Right. But if we can optimize where those dollars and cents are going, it's only going to make anything better for those managements. So on general observations, when we're looking at sort of any sort of soil mapping technology, but of course with SoilOptix specifically, what we're seeing, of course, is increased yields maybe on wheat, 2 to 20 bushels, canola 3 to 14, sunflower, let's say 297 pounds, potatoes, of course, corn. But overall, if we can start to see higher quality, better protein, earlier harvest, better standability, and even more crop. This is what's going to get us through to this, coming back to that original definition with precision ag, a more sustainable agricultural production system as we go through. So just to sort of wrap up, again, this toolbox is filled with so many technologies, and it's now time that we can start to introduce high resolution soil mapping technologies to complement the other high resolution data sets that we do provide or gather, let's say, from the field with other technologies. And it's trying to find these pockets of opportunity, right? Optimizing, again, those dollars and cents that are going into the field so that we can provide a better, valuable soil information data layer so that we can be better into our management decisions in the field. At this point, I'd like to thank anyone that is online today for listening to the presentation. If you have any questions, by all means, I'll be here through the conference on private chat, but feel free to reach out at my email there, call our office, or if you're in an area with a SoilOptix service provider, you can find their contact info as well at SoilOptix.com. Thank you so much for the time today, and I'll send it back to Ainsley.
Thank you, Zach. That was great. Yeah, so we'll open the floor now to any questions our attendees might have. Feel free to post them on FeedLoop or on Zoom. No questions at the moment, but we did get a comment from Lisa saying, great presentation, Zach.
Thank you, Lisa.
Still no questions, but actually I'm quite curious. So how often does a field need to be surveyed by like the SoilOptix sensor? Like, does it differ in crops?
Oh, that's a great question. Yeah, it comes down more to let's say the management from a tillage standpoint. Typically, we would say on average you're not going to need to resurvey certainly in the first 6 years. If you're in a minimum till, no till environment where you're not getting a soil dispersion or anything like that, or no major excavation in that field, that can easily be extended out to 8 to 10 years quite often. So certainly in more permanent cropping systems, listening to Chuck Barisich's discussion today on certainly in the weeding and more of the horticultural or permanent cropping systems, that's where we can really extend that out to easily 10 years, quite easily. So, yeah. Okay. But again, you can resample every 2, 3, 4 years, whatever fits into your resampling or your sampling schedule. So.
Great. Thank you.
Awesome.
Well, I guess there's no other questions, but as you mentioned, Zach, your contact information is attached, and our attendees feel free to head over to the exhibit hall where you can see SoilOptix's booth, or go to the networking tab and you can connect to Zach one-on-one.
Yep, wonderful.
Perfect. All right. Well, thanks again, Zach, for your time and for your informative presentation. I hope everyone has a great rest of the day.